Make sure your students signed in.
Sign in. All righty, folks. Thank you for joining us for our second honors program colloquium of the fall 2022 academic semester. I'm very excited to be welcoming my colleague, Dr. Sulaman Pashah, Assistant Professor of Mechanical Engineering, who will be speaking to us on the effective use of PowerPoint for enhanced student learning. So, Dr. Pashah.
Thank you very much. And thank you for coming and joining for this presentation. Basically, this is just, I just want to share my experience. I have been teaching for the last 7 years now, and this is just how my teaching material has been evolving over this period. So let's start.
You might have to click on the center part, sorry. Yeah, now you might be okay. No, maybe not.
Yeah.
There.
So basically the scope is being a faculty of mechanical engineering, it is always a challenge to cover complicated concepts over limited duration. So it would be very much the same today. I have a limited time and I would try to not go very fast, but still try to convey the messages I want to. So just to start with and put the context, there is a publication. It was back in 2003, and the title is really very interesting: the use and abuse of PowerPoint in teaching. So now this is a standard platform to teach are the PowerPoint slides, and what are the good attributes of successful presentation using PowerPoint. So this is what I'm doing right now, that rather than flashing all the material, all the slide at once, it's always smooth if you are presenting the material stepwise. So like that, the listener is not distracted. It's not going throughout the slide, rather than it can focus on the point which is being discussed right now. The next is appropriate background. Now we have the accessibility tools incorporated, but usually I always like to put plain white background. It gives me more space for the material, and I don't really go for the fancy backgrounds. There is nothing bad in that, but that's a personal choice. As we say, a picture can worth 1,000 words. So just as an example, if I show you here, okay, so this is one of the slides from thermodynamics, and the topic is that how we can convert energy from a flowing fluid to a mechanical work. The very first example, as you can see, that the flowing fluid can be used to turn a wheel, or it can be a wind turbine. But our main topic is rather steam turbine. So when we see these two examples, it is easy to see that with this setup, my working fluid is rather steam, which I am producing by burning some fuel, and I'm converting water into steam. And this steam is basically rotating this turbine, which in turn runs a generator in order to convert heat into work. So this picture provides a very good understanding of how heat can be converted into work by showing some nice pictures. So it used to be pictures, but now we have very nice animations. So I use it whenever I find. And then the next is, the further step is videos. So we have now access to video. So for example, here, what I'm trying to show is that in the same context, when you are trying to boil water to get steam, the thing is that you can boil water at any temperature. We know that water boils at 100 centigrade, but it can be boiled at 1 degree centigrade, or it can be boiled at 50 degrees centigrade, depending upon if you provide necessary pressure. So here in this video, what is shown, if you see the video, it is 4 times speed, and basically you will see, this is the definition, the triple point when the solid, liquid, and gas, it means the ice, water, and steam, they are acting at the same time. So this is the portion which is solid, ice, liquid water, and what you will see is that this water will start boiling, and this boiling is occurring at what temperature? 0.01 centigrade, which is very much near zero, freezing point. But freezing point if your atmospheric pressure is 1 atmospheric, whereas we are at almost 1,000 of an atmospheric pressure. So what happened is that with the passage of time here, you can see that the bubbles are coming. This phenomena, this is very well, we are very well aware of that when you boil water, you have these bubbles. So basically this is boiling water, but at 0.01, thanks to the pressure, which is very low. And at this pressure, what happens is that water can coexist in equilibrium at the same time, solid, liquid, and gas. Now, if I try to explain this just by using this sketch and reading this, as a student, I never understood that. I did not have YouTube. I did not have enough resources. But now we have access to all these resources and we can use it. You can see that what is boiling, it's at the same temperature. Still, I can see the ice in. Okay. Again, while you are presenting, it's always better to use transition slide between the sections. We should know that we finished with the first topic and we're moving to the next topic. So this is one of the good practices. The second thing is how many slides should be there. So naturally, according to this source material, 50 to 20 slides or 50 minutes of lecture, but it depends upon what contents are there and what is the topic being discussed. Now, the most common abuses of a PowerPoint used for teaching. Poor or boring slides, which gives the feeling of sleeping, because most of the time I'm standing here as a teacher, but I know that sometimes if I'm sitting in a seminar right there at your place, it's quite challenging to be concentrated depending upon what's being presented and how it's being presented. So sometimes it happens in the class. If I see my students are getting bored, I try to create a communication to ask what is not going well and how things can be improved. So I would like to quote one of the physics professors, which says it's a crime, basically, to teach physics in a boring way, because physics, basically, all the engineering topics are advanced application of physics. So there is so much you can do it to make it interactive and interesting. And if you are just teaching it in a boring way, it's basically a crime. Okay, the presentation should be used in bullet points rather than putting all the paragraph of text. We know that inappropriate use of text multimedia. So I put this. So if you are using the multimedia effect again, okay. So unnecessarily, it is there, it makes fancy, but does it really require? If yes, why not? If no, it can be avoided. Going too fast, if you have too much material on the slide, naturally you cannot go through all of that. So it should be a support for your talking rather than putting the material and reading it. And the last but not the least, this is the biggest challenge. You go for the class and you find that the multimedia is not working for one reason or another. Then it's a bit difficult situation how to conduct the class. So there should always be some backup what to do. Okay, so here is the presentation outline. I will be going through these 8 topics. I'm not going to read all of them because I will be going one by one. And then I will be finishing my presentation with the concluding remarks. So I will start with the very first, which are what are the very useful, I found them useful keyboard shortcuts during presentation. So the very first thing is, if you press Control P, what happens is that you can use your pointer as a pen. And naturally, I should be able to erase it. So in order to erase it, you just press E, it will go away. If you want to use it as a highlighter, it says Control+I. So if now my pointer is a highlighter, I can highlight. And if I want to erase, again, I will use E. If I don't have this pointer here, for example, if I don't have this pointer, I can use my arrow as a pointer. And how can I do that? Control L. So if I do Control L, now you can see that this is like a laser pointer, but this is a continuous. So it is continuously as a laser pointer. But if you don't want continuous, rather you just want as per need, you just keep and hold Control, and then whenever you will be clicking, then it will be becoming a laser pointer. So if you don't have a laser pointer and you want to use it, you can use this shortcut. Sorry. Okay. The next is, this is very useful, that if you want to jump between the presentation, you want to go, for example, if I want to go from slide 7 to slide 5 for any reason, I just have to put 5 and enter, it will go to 5. And I want to go back 7, I can come back 7, and the utility is that my current status of the slide is still at the same location. So if you want to go back and forth without losing the current state of the slide, then you can move. If you are taking a pause, you just press D, it will just make your slide black. So if this is a discussion and you don't want to display, and then naturally you can come back, either B for black or W for white. And if you want to see what are these options available, so you just press F1 while you are in presenter mode, and it will give you under tabs what are the different types of shortcuts which you can access. So it is very handy. If you don't even remember, you can just press F1 and you can go, for example, here for laser pointers, and then you just press OK and you can come out. Okay. Next, I will be showing you what is the textbook material for a particular topic and how it can be converted into more understandable material. For example, this example is how you are going to convert water into steam. So naturally, we have to heat it. So this is initially water at atmospheric temperature, room temperature is 20. And basically, this is a sliding boundary. What is the purpose of the sliding boundary? It will not let water vapor escape, and it will keep constant pressure, because you know that whenever we are heating something, it will try to expand. If I am constraining expansion, the pressure will rise. So I want to keep the pressure constant. So what will happen is that while I'm heating it, water will expand, and this one will let it expand without creating the pressure. The pressure will remain constant throughout. And due to the temperature, what will happen is that the temperature will rise. So if I keep on heating it, the next milestone will be when I reach to 100 centigrade. So I started heating it at 20, and I reached to a point 100. The pressure is exactly the same because of this moving boundary. And now this is the very first milestone. And what happens at 100 centigrade? The water starts boiling. It means it will convert from to gas. So what will happen is that it will start converting into gas, and now the volume will start increasing quite rapidly, because the gases take much more space than the liquid. And the important thing is that the pressure is always the same because the volume is increasing. And the next milestone will be when the boiling completes, and all the water now has been converted into vapor. And what is the important point between these three is that when the boiling starts, it starts at 100. And during the entire boiling, the temperature remains constant. That's what is the property which is called latent heat. So when you are boiling, the temperature does not increase, rather it remains constant. So boiling starts at 100, unless boiling finishes, you have 100. And then if I do not stop and I keep on providing the heat, what will happen is that the temperature of the vapor will start increasing. So this is the process we have to study. And we have to study using this picture, this process diagram. Now, I explain this, and if I come to this, it will be having a very hard time explaining how different states are located on this process diagram. So what I did is that I started making my own. Content is the same. This is just the rearrangement. This is the very first point. This is my temperature versus volume. So initially, my temperature is 1 with a certain volume. And then what happens is that when I start heating, the next milestone will be at 100. And what happens is that I can show that from here to here, the temperature will be increased, as well as volume will be increased, but slightly. And this will be due to the thermal expansion, because whenever things are heated, they expand. So the next point, this point can be here, which is corresponding to 100, and the volume will be a little bit more because this is my volume. And then what happens is that I know that once the boiling starts, after that, the only change will be volume, because the thing is that the water is converted into gas, so it will be increasing at volume, but keeping the same temperature. So the next point will be on the same temperature value, unless you complete your boiling process where there is no more liquid and you have entirely in gaseous state and the volume from here to here has increased considerably. So the thing is that from 2 to 4, it is just the increase in volume, keeping temperature constant. And the next step is when I am if I continue heating process, now both the temperature as well as the volume will increase. So the point will go both to the right and top. And then I can show that between 1 to 2, it was liquid state. From 2 to 4, it was a mixture state when both the liquid and the gaseous state were existing. At the state 4, it was completely gas, and further heating will not only increase temperature, but the volume as well. So it makes things rather quite convenient for me to explain rather than using the static images from the textbook as my teaching material, because these are stepwise generation of the entire process diagram. Any other example? The second example is the dynamics course. So dynamic means motion. I have to teach that how to study the motion of this particle. And if I'm using this static image, naturally it will be very hard for me to explain and not very interactive for the students to see what is going on. So here I had to put time and effort. This is the final slide of the of this topic, of this particular dynamics topic. And here I am showing that what is the difference. So here, for example, I give you an example. If I leave my office at 3 and I reach my home at 4, and in between what I was doing, I was picking my kids from 3 different schools: elementary, intermediate, and middle. So I was doing some back and forth motion. But the thing is that on average, if I give you the information, I leave at 3, I reach at 4, and the distance is, let's say, 10 miles. So my average speed was 10 miles per hour. But this is an average speed which loses all the intermediate information. All this intermediate information. So if I give the average velocity, what does it mean? I say I start from here, I finish from here. So it is just no intermediate. But if I want to incorporate that, all this information, then it is what is called instantaneous velocity. So here is what is the difference. So you can see the difference of the movement of this particle here, which is just telling I leave at 3, I reach at 4. Here I will be telling that I reach at 3, I go to elementary, then I go to secondary, and so on, and I reach at 4 at my position. So this is the difference. So if you see here, this particle is having back and forth motion at different instance of time, and at the end instance of time, both have done exactly the same start to end motion, but the difference is large. That this is instantaneous, just providing you what was happening at each instance of time, whereas it is just an average value. You start from here and here. So with this, it takes time and effort, but I think it helps students understand what I'm trying to explain, and it helps me a lot and feel better that I can explain things in a better way. So if I have my PowerPoint material in this format already, it is really very easy. You can convert these PowerPoint slides into a video lecture. How can you do that? You have a tool tag, very standard tool tag, file. If you click on record, then what you can do, you can just click here and you can start talking, and you can forward your presentation. It will start being recorded as a video lecture. You can keep still in PowerPoint format. The benefit is size is very low, but you can save as a video. The benefit is it's fixed, but it is very large. So here I can show you that the same example which I showed you here, this example, how it looks like in form of a recorded video lecture. So now we'll click and it will start running like a video lecture. So this is basically a recorded lecture. So it will be working by itself. So what I did, I was just doing it. If you see this, it is just following all the steps. So if the students are looking at it, it is like a recorded lecture. It is really the most convenient way without use of any additional technology. On your laptop, now you have your built-in microphones. That's it. You can make it and you can upload it as a recorded video lecture. Okay. Another thing I like to use colors a lot, you have seen. What's the purpose? The purpose is this is a 3D vector diagram, and I have to explain this to students. So if I use just black and white, naturally it will be very difficult. So the very first thing what I do is that I convert into colorful with a sense that X will always be green, Y will be pink, Z will be blue, and my resultant is in orange. And then I can easily tell them that the very first thing what I have to do is that I have to resolve this into Z and Z prime components. And then this view is basically 3D view. So just to show you an example, if you see it from this view, you see it as a line. But if you see it here, you see an area. And if I see like that, if I make it a little bit like that, so it is not really a rectangular area. So if you see here in this view, basically this is a right angle triangle, but as it is shown in 3D, so you do not really see that this is 3D. So what I do, I'm trying to show you that if you are standing on the right perspective, what is the corresponding 2D view? And this view is really very convenient for the student to resolve this F into two components, which will be along Z and Z prime. So I show it exactly the same way using the color code, that what these two lines correspond here. And then what I can do, I can continue showing that what FZ value depend upon which of these components using this color code. And I am developing the sketch in addition. So what happens is that by the end, the sketch becomes quite complicated. If you see that, the end is this sketch I have to use. So if I was using it as a static image, and I'm trying to explain all this without these additional sketches of color, it's not easy. At least I don't feel good about that I can always go, I can teach and I can come out. But naturally, I feel it more enjoyable for me to explain. And I feel that the student can have a better understanding with all these additional details. So the next one is again that I just fast forwarded. So these are stepwise. And then the next is last, how this vector is making angle with x-axis, y-axis, and z-axis. So the thing is that a complicated image with the colors and stepwise development, it makes it quite easy, if not easy, convenient for the students to follow up how this complicated sketch was developed. Okay, so the next thing is, as you have seen that there are lots of equations which are there. So I got a very nice tool, and this is free, by the way, Mathpix. With our Texas A&M University email, you can get up to 100 snips, and one snip can be the entire page. So if you do the entire page, you can do an entire problem in one single snip. What happens? The source material from the textbook is an image and the equations which are in form of image. As this is an image, I cannot edit them. So the thing is that this tool, if I just snip it, it will convert it into editable text. And then what I can do, I can export it as a document form, or I can directly copy to paste it in a document format. The only requirement here is that if you copy it from here and you paste it in PowerPoint, it does not work. So you have to pass through the Word document, you open Word document, you copy from Word and you paste it in PowerPoint, it works. But if you copy directly from here and you paste it in Word, in PowerPoint, it will not work. Okay, so the thing is that here now these are editable text. Once I get them at editable text, I can put colors with purpose in order to make things more interactive. Okay. What I do is that I don't rely only on the material from the PowerPoint. Rather, what I do, I create my own explanation in terms of animation. So if a body is there without any force, it will not move. If the body is acted upon by a force, it will move in the direction of force. But if a body is held with the support and I'm trying to move it, it will not move. Why? Because naturally, this support is providing a reaction in order to not move. So that's how I can better explain what are the three laws of motion for Newton, and this is the base of mechanics. And then I can show them how to use this information for analysis of actual structure. So the very first thing is for idealization, that what I am doing, I am converting all of these loads in terms of the external applied load. Here, this load is the external applied load. And then this information that any support will not let it move, I have to replace these supports by the corresponding support reactions. So how do I do that? I do it by showing that if you imagine that this support under the influence of this force, what will be the movement? This will be the movement. But the thing is that when the structure is intact, it is not moving. If it is not moving, it means that there is a support reaction which is opposing the intended direction of motion. Very much the same in this scenario, this will be the intended motion. But that the structure is intact, what does it mean? Your support reactions must be a rotational effect as well as a translation effect. So, and then I can relate it that these actual support systems can be idealized as a roller. Why? Because this one will not stop any motion in horizontal and will only stop motion in vertical. And like that, you can replace this support by this idealized, which will give you this final reaction. Okay, the use of hyperlinks. I will just take 2 more minutes and then I will finish. So this is a typical type of problem in thermodynamics. I show the problem statement, sketch. After discussion, what is required, what is given data, what is required data, what is the schematic of the problem. So we do it with all the discussion. Once at a point we reach that this is the data point of interest and I have to get the data. In order to get the data, they have to go and look in a table. So what I can do is that I can insert the table here and I can go to the table without losing the continuity of the problem discussion. I show that this is my corresponding data values 20, 280 and 8.5. And then I can go back. Okay, I can go back and I can report here the data that this 280 and 8.5 are the data values coming from this reference table. So use of hyperlink, you can put this data somewhere in your at the end of your presentation, and you can go and fetch the data for the further calculation. Okay, the last thing is I use internet resources, the animated GIFs, all the videos. So I always try to put the reference. So this is the title slide of each of my lecture notes. So it gives credit that all the material is based on this particular textbook. All the material is from the textbook, apart from some additional illustration. If there any illustration is coming from the internet, I try to put hyperlink. I have to do a little bit of more work about this citation work, just to avoid violation of any copyright. But I try to give credit. That's the minimum I'm doing, but I know that this is not enough, and I will be trying to see what are the most of the things which are coming from Wikipedia, they are open source. With this, I come to the end of my presentation. So the thing is that I realized when I started teaching that taking the material from the textbook publisher and start teaching it is a good idea because it gives you hard time for explanation. Okay, it covers all the material, but it's not best for explanation. So you can create your own material. It requires considerable time and effort. Converting the sketches, all this stuff, it takes a lot, but it's worth it. You have done it once, you can use it again and again, and you know that what are the aspects you are not going to miss because everything is recorded in your PowerPoint slides. And it provides, I feel, a better experience for the student. And the thing is that it's a continuous improvement. After most of the time, if the students ask some questions, and I think that these aspects can be included as an explanation in the slides. So I do update continuously my slides. With this, I come to the end of my presentation. I really thank you for your time to come here and listen to my presentation. Thank you very much.
I don't actually know what time it is, so I didn't bring my.
12:48.
Oh, we got, any questions for Dr. Pashah?
Yes,
What class do you teach?
I teach mechanical engineering courses, thermodynamics, mechanics, statics. I would love to teach physics if possible, but I think that I'm already overloaded with mechanical engineering courses.
Any other, I must confess, I'm embarrassed to admit that I didn't realize you could blank the screen by hitting B. That's a lot easier than what I've been doing. So I think we have a question on chat as well. That's one of our.
Yeah, those, that page with all those little hotkeys is really
Oh,
nice.
thank you. Thank you. Yeah, I've been using PowerPoint for well over a decade, and yeah, people don't know that.
I didn't know.
Good. Well, thank you. You and I should be ignorant together.
Justin Vicky says the control plus T trick is a game changer.
Thank you.
Everybody likes it.
No, that's good. That's quality stuff. Any other questions? All right, well, in that case, thank you again, sir. Very much appreciated. And yeah, well done. We'll get another round of applause. I will go ahead and get this posted up on our what do you call it? YouTube page. Yeah.